Hello, everyone, and welcome to today's webinar on bringing data closer to decision makers with Data Fabric. Today's session is done in collaboration with Blur Research, an analyst company based in the UK. I am super happy to welcome today's speakers. We're joined by Andy Haler and Stephen Crook. Andy is a practice leader at Blur Research. He is an industry authority and an independent consultant for corporations, venture capital, and software companies. Stephen is a principal sales engineer at Progress Software. He is an expert in software development and database solutions and has a deep expertise in our Progress MarkLogic and Progress Semaphore solutions. Welcome, gentlemen. We're super happy to have you here today. A quick note before we jump into the topic of today's session. Please use the GoToWebinar questions panel to submit your questions during the discussion. At the end, we're going to open the conversation for your questions and answer as many of them as we can.
Okay, so yeah, there you go.
What we're going to be talking about today are modern data architectures and data fabric specifically. We're going to cover benefits and challenges of data fabrics, the semantic layer and how it works. We're going to touch on use case suitability and go over a couple of successful data fabric deliveries. At the end, again, we're going to open the conversation for your questions. Data fabrics are one of the approaches organizations take to blend the need for business data with the need for structure that is optimized for security and governance. Modern organizations are laser focused on delivering business value from technology initiatives. And in fact, a recent study by AWS found that about 60% of chief data officers tie data infrastructure improvements to specific business decisions and initiatives that are run across the company. That means they're working closely with their marketing and business leader peers, and this is never an easy task. What we see from the field are generally three hurdles to delivering business value from data projects. The first one is associated with enterprise architecture, and when decisions are made of data projects being treated as actually IT projects. The second hurdle that organizations need to jump is the convergence of data operations and data quality processes. This is the step where organizations are faced with the challenge of empowering business users who are close to the data and understand the data to actually contribute to the governance process and bring their input into improving the data quality. And the third hurdle is associated with the mechanisms that organizations leverage to deliver data and insights to their subject matter experts. A common solution to this third hurdle is a metadata-centric approach to complex data challenges. We are well into the active metadata era when it comes to data architectures. Data fabrics, data meshes, and knowledge graphs use a powerful combination of data, metadata, and a semantic layer to deliver on business requirements for data discovery. All of these architectural patterns come with certain challenges, which is why some people are talking about a hybrid approach, or what is sometimes known as a data mesh 2.0. With that, I would like to give the floor to Andy. Andy, it's over to you.
Sophia. So we're going to talk about data fabric, having had that general introduction, and we're going to really sort of dive a little bit into what data fabric really means and how it would be different to, in particular, sort of data mesh architecture. Traditionally, I mean, in the past, if you go back a few years, certainly when I was running projects, then Shell and other companies, then most corporations used to copy data from their source systems, maybe their ERP systems or supply chain systems or Salesforce type systems, into a dedicated place for analytics. So a data warehouse. And a few years later, with a lot more unstructured data being around, that sort of morphed into a similar approach, but with a termed as a data lake, which was a sort of similar kind of idea, but more focused on unstructured data. Now, when you're copying data about from various source systems, and there are a lot of source systems, so typical large company will have a few hundred source systems, of which only one probably will be its ERP system. You clearly have some sort of issues around that. You would certainly want to be making sure the data was accurate and correct. And there will be some degree of duplication of data, particularly around certain data types like customers and products that'll be stored in more than one place. So you're going to have to sort of resolve those inconsistencies. And that's the kind of thing that you do when you're building and loading and constructing and designing a data warehouse or a data lake. And the advantage is that you get one single trusted source, which is great. The drawback is that the data warehouse structure itself can be rather brittle. If, for example, there are underlying changes in the source system, so somebody redesigns the marketing hierarchy or product hierarchy, or there's maybe a merger and acquisition and you have to bring in new systems from other places, that's fine, but you have to somehow make sure the data warehouse is fully up to date with that. So this can, if there are enough changes going on, and if it takes you quite a long time to implement those, then the data warehouse itself can become rather out of date. And that's quite a challenge in a lot of companies, who are, particularly those who are doing a lot of mergers and acquisitions or reorganizations. So that is one sort of problem with that kind of approach. Also, because you're copying data around the enterprise, there may be very large amounts of data. That's typically done in sort of batch processes, often overnight or maybe hourly, something like that. But rarely in real time, due to the sheer volume of data. And some analytics requirements may be real time, so that may not work for everything. And it could be argued that the data warehouse or data lake in itself is just collecting data from all these silos, but you could argue that in itself it's another silo. So although it's been a fairly well proven method, it's something that does have some potential drawbacks. And so we'll see there's some alternative approaches have sort of come up in the last few years. The idea of a data fabric, it had the same idea as a data warehouse, which was you want to have the business users having one nice way to access their data, or in a relatively comprehensible sort of fashion. But wouldn't it be nice if you could do that without actually having to copy all the data around? And certainly, in a sort of ideal world, that sounds appealing because you remove all these drawbacks that I just went through. So in this approach, you would have what's termed a semantic layer, something that maps the data assets in some kind of, you can think of it as a sort of treasure map or something to your data, and represents these data assets in some friendly visual fashion. So it won't probably be the physical table names, in SAP, something like KNA1 is customer master, or people don't really want to have to remember all that stuff. They want to see something like customer or or product. And so this sort of semantic layer removes any of these sort of difficulties in the physical layer, and usually brings all that together in something called a data catalog. And once these data assets are gathered and documented in data catalog, probably automatically reading database schemas to keep up to date, then they'll be displayed in some kind of visual form. There's a sort of modern interpretation of this called a knowledge graph, but it may be other kinds of approaches too. But something that's basically intuitive to the end users. And the idea is that the business users can access their data once they can find it in this way. And this could all sort of happen without having to do bulk copies of data into a dedicated place. So what does it kind of look like? Well, if you imagine the consumers, the data consumers, maybe business analysts or whoever is trying to access some data, that perhaps they're trying to understand their sales for the last quarter or something like that, they will see at the top layer this kind of visual representation of their data in some form, say maybe something called a knowledge graph, maybe something slightly different. But the idea is it's a sort of user-friendly version of things like customers and products and assets, in a way that's very easy for them to drag and drop and see relationships and so on. And that's all represented via this sort of semantic layer, which is essentially a layer of active metadata which underlies that visual representation. And this itself is driven from a data catalog, which is like the documentary source of all these data assets, and also may have rules that go beyond just simple display, may also contain information about data governance, so things like who actually owns things like product or asset in the organization, who are data stewards for these kind of pieces of data, that kind of thing. And as you go down through the layers, obviously at some point you need to actually go and get the data. So once the users say, okay, I want my products and by customer for the last 2 quarters, at some point they're going to press a button and actually something has to happen. So there's a layer of integration and orchestration of that data that has to occur for these things to actually happen, and for SQL queries, if it's assuming it's structured data, to be issued, or if it's unstructured data, perhaps it's calls to APIs. And this may, depending on the exact sources of the data, if it's great if they're all in one place, but as I say, probably the data is not in one place, so it's probably in many different databases in different places. And if that's the case, you may require some kind of distributed or federated data query capability, which is a very sort of specialist technology that not all databases can do or do very well. And these are the sort of layers that are really sitting on top of your core source systems. So let's talk about the difference between data fabric, which is what we discussed, and data mesh. The ideas of the two are very similar. I mean, you're still trying to do the same thing, which is give its end users a sort of cuddly access to their data, some sort of treasure map of their data assets. The difference is really primarily in the way that the governance or ownership of data is handled. So with the data mesh, the idea is to focus on producing data assets, as they will be termed. So something like customer or product will be the sort of end result, and that would involve particular business users being assigned ownership of those things. And it may be certain departments that have the really own something like the product data, someone else maybe own asset data or customer data. And the idea is that in the data mesh world, that ownership and governance is fundamentally devolved into distributed business units. The idea with data fabric is that governance is essentially managed on a more central basis. So that's really the core sort of difference between the architectures. I mean, there's a little bit more to it, but essentially at its heart, that's the difference. And because, in fact, in truth, some things make more sense to be centralized and some things make more sense to be decentralized, and because it's also driven by the particular cultural and political structures of your company. So some companies are very centralized. I mean, I used to work for 2 big oil companies. Exxon was super centralized, Shell was very decentralized. So it may be that different architectures fit better into different corporate cultures and architectures. And the idea, the latest twist on this has been something called Data Mesh 2.0, which has been a sort of a little bit of a hybrid of the two, where certain things make more sense to perhaps be centralized, and other things make more sense to be decentralized. So it's a sort of, kind of a little bit of a twist on these two different approaches. Now, to actually put one of these data fabrics in place, this all sort of sounds sort of great, because essentially you're achieving this, in theory, this sort of nirvana, without any cost, and essentially all that pesky copying data around, and all that data quality and merge matching and all the survivorship rules and all the things you have to do when you're building a data warehouse, that all suddenly disappears into this semantic layer. And so, as you can imagine, there may actually be some, a reality check applied here. Certainly, the tasks of removing duplicates is still got to be done somewhere. So, in a survey that I did a few years back, the average large company had 6 different master sources for customer data and 9 different master sources for product data. That was the average. Some had a lot more. So think about that. So 6 different systems claim to be the single customer master. But obviously, a bit like the old Dire Straits song, 2 men say they're Jesus, one of them must be wrong. Not all 6 of these customer sources can be the true and one only definitive source. So you do have to do some work here to figure out which of these is correct. And that's normally done through a sort of process of defining something called survivorship rules, which you would do in a master data management system, or perhaps in a data catalog today, but it still has to happen somewhere. The second issue you come to is actually issuing the query. So assuming for a moment we stay in the structured data world, we've got very large data warehouses, and some of them can be huge. I mean, they're petabyte-sized data warehouses are not so uncommon these days. If you're trying to write a SQL query against that, if you're a skilled programmer, that's still not a trivial thing to do if you want the query to come back, in a few minutes rather than a few days. Now imagine that instead of running that query against a single dedicated, carefully optimized data warehouse, that you're suddenly trying to run that query against a whole bunch of potentially different source systems, which are operational systems. They're not optimized for query particularly. That efficiency issue is going to be quite sort of tricky woo, as we say. You've also got to think about how the semantic layer itself has to be kept up to date. Before, we said that the data warehouse structure could be brittle because things can change underneath it in the source systems and have to be reflected back in the data warehouse schema. Well, if that's the case, then that's also true of the semantic layer. So if new operation systems come in, there is reorganization in some kind of change of marketing hierarchy or something, that has to be kept up to date in the semantic layer. There has to be some process to make sure that everything is completely updated. And finally, distributed queries, particularly across multiple sort of potentially alien databases, are not trivial and a very specialist subject. You need a particular kind of database optimizer to do that. You may not have that in your traditional database, which is usually all about working on its own data. It's not usually very good at flying off to foreign databases and trying to somehow on the fly produce SQL queries. Another issue is that if you're giving access to data to this sort of semantic layer across the enterprise, you do have to keep considering security as well. People will have potentially different levels of access. Of course, some of this will be handled in the database layer itself. But you also have to think about things like, do they have access, but also what about personally identifiable data that might be in some of these source systems? Do you really want to give access to all of your business users to that? Probably, possibly not. So there's some sort of approach you need to take to possibly may involve masking of some data, that kind of things. disguising credit card numbers or social security numbers, that kind of thing. And that would usually be documented at least in the data catalog, but that still has to be implemented, and rules have to be sort of carried out to make sure that this actually happens. So in reality, the the putting in place this kind of modern data fabric architecture is, while it sounds sort of like a bit of a nirvana, because you get the answers to all your questions without any of the work. In fact, that nirvanas rarely exist. And in real life, much of the work still has to happen. It just may happen somewhere else. So instead of maybe in a data warehouse, it may happen in the semantic layer or in the data catalog. So there's still quite a lot of issues to deal with, and it may well be that there's perhaps arguably there's probably possibly no single vendor that has every single one of these components, from knowledge graph through to data catalog, through to semantic layer, through to data integration, through to federated query. And you may well need to sort of plug together or weave together, if you'll excuse the tortured pun of cloth and fabrics, that weave together these pieces from potentially more than one vendor. There are certainly some vendors who have quite a few of the pieces, and some of those may be quite integrated, but there may well be a certain amount of integration work you need to do to pull this together, particularly if you want sort of best practice technology in some of these layers. So something like distributed query, as I say, is kind of hard, and that may not be something you can find necessarily from one of your current vendors. So that's the sort of summary, really, of the kind of challenges that go along with a data fabric architecture.
I hear data integration is a challenge in its own right. Sorry, not data integration, but vendor and solution integration is a challenge in its own right here. That's a long list of challenges indeed. I'd be curious to hear, Steve, what's your observation? How do customers actually tackle these challenges?
Well, I think, say, if we start with maybe the semantic layer, so there are tools out there, and of course, we can talk about what we do here with Progress, but certainly there are tools that allow you to create those knowledge graphs and map all those conceptual ideas over into the sort of the practicalities of how you actually access the data down in the depths. But certainly, yeah, we've done that before. We do that on a regular basis, and we've got some use cases that we can talk about. Security, that is an interesting one, because you can come up with these great ideas and then take it to your head of security, and you just get shot down. And so it's important that you're able to create a unified security model. And one of the things about Progress's logic database server is that you can work with a variety of data within that platform. So, for example, rows and columns, you can work with documents, you can work with graphs, and apply a single security model over the top of that information. And then with regards to deduping and merging of records, we have what we call a smart mastering capability. So the idea that you can take multiple sources of data and have sort of survivorship rules to determine an ultimate accurate true record. But I mean, in terms of the idea of federated queries, I would agree that's that's a tough problem to solve, because you've got different SLAs for each of those silos, and you've got different ways of accessing that data. Plus the fact that once you actually get access to it, you've still got to have a layer in the middle between your user and that data that's actually going to do complex joins and aggregations. So you've got to think about how you're going to do that, and is that realistic? Is it realistic, and can you get the performance and the real-time queries that your users are demanding?
So what would you say customers actually prioritize in the different types of situations that they find themselves at? There are companies that have to do with legacy systems that cannot be completely ripped and replaced. So they need to do the best out of the situation that they're at. What would you say are criteria that customers would prioritize, organizations would prioritize when it comes to their choices?
I think if you're talking about an archival system, then you're probably looking at queries that don't really need to have to be run in real time. And yes, you can store maybe the majority of that information, in their original source, pull it out via APIs, and have a tool, maybe a tool that will go through, middle layer that will go through and work with that data to produce a result. However, if you're talking about real-time mission critical, then you've got to, that's a different set of challenges. Again, security is a key thing, and performance is true as well. So, whether there's, when it comes down to it, what would you rather do? Have performance, but you have to sort of consolidate some data, or the lack of performance and maybe security rules, but and the fact that it's more of a challenge to join that data, but you've got this purist approach of storing the data, leaving it in its silos. There's I think what we need to realize is that these fabric and mesh, they are architectures, they're frameworks, and there's still a lot to be done within the industry to realize the true goals of what these approaches are about.
Would you say there is a good traction when it comes to the hybrid approach?
Oh, absolutely, yeah. So, well, in fact, again, because they're architectures, that doesn't mean that they can't be used together. And in fact, quite often companies do exactly that. They'll take the good pieces of the data mesh where you've got a data product. So each, for example, silo, they create it as a data product, and but then make that available within the context of the wider fabric. And when you then bring in say mesh 2, where you've got say a centralized governance platform, and also maybe more of a centralized infrastructure platform, that helps to reduce the friction between components and ultimately results in faster time to market. But yeah, absolutely. I mean, you can blend it as much as you want.
And I'd be curious on your thoughts about combining different parts of different architectures into a mix and match approach, what you've seen.
I think that's sort of realistically, it depends, as I mentioned earlier, a little bit on the type of, on the kind of companies you're dealing with. Let's say some companies are highly centralized in structure, which may suit, a very centralized governance approach. Some companies are very decentralized. Something like Unilever or something is an example of that. Highly decentralized, lots of autonomy in the operating units. For those, it probably makes a lot more sense to be much more focused on a sort of data mesh type devolved structure. And for other companies, it may be it's a little bit of both, where they want to manage something centrally. So for something like a marketing hierarchy, you might decide that there's a sort of high level classification for certain of your brands, your maybe global brands. You want to manage those centrally, but equally you want to give your operating units flexibility to have additional local products which are tailored to a local market in a certain country, in Vietnam or France or Canada, or particular states in America perhaps as well. So you may well find it may be appropriate to mix and match, depending as much as anything on the culture of the company, I think, as any sort of technology issues.
Steve, did you want to add anything?
Oh, well, just that we tend to take an approach that that you let's say you have all these silos, and we're very good at storing the metadata, the knowledge graph, and we've got that the ability to query those graphs within the MarkLogic server. So typically, what we'll do is we'll get the metadata in the knowledge graphs. That allows us to to store essentially a model of that data, and then rather than kind of boil the ocean and say, right, well, let's bring every single, let's destroy all those silos within the organization and bring it into MarkLogic. That's not really a practical approach. What we'll do is we'll say, well, what is it that you need to solve this particular use case? So we bring in just enough data from those disparate silos into MarkLogic to store and work with the problem at hand, so that we can make it available to downstream systems. Progress semaphore is, and we're going to come to it in a minute, is the way of allowing us to model the data. So, for example, from the conceptual, the logical, all the way down to the physical, so that we can then use that to query that data within the platform.
Okay.
But what that does is it means you're not having to deal with the federated query problem, which is significant. You've got a unified security layer, and you get the performance knowing that it's in a single platform.
Let's talk about the semantic layer then. What it looks like, how it works, and how technically we can approach the integration of one into the architecture pattern.
Right. So let's start with the bottom layer. So you can see all those data sources down there. So you've got, let's say, CRMs. You've got your data lakehouse, maybe files on shared drives, just as literally as files. But you've also, what you've got to realize also is that the data will be in various formats. So it'll be in, might be lines in a CSV, could be tables from a relational database. There could be documents from something like SharePoint. It could be graph data. So very few platforms are able to work with all those types of data. What they'll typically do is they'll massage it into a form that's right for them. So maybe if it's a SQL database, they'll massage it into rows and columns. If it's a graph, they'll probably tripleize everything. And of course, the problem with that is that because every single data point is a triple, when you're working with graph data, you end up doing a ton of joins. So our approach is to work with the data, because we can natively work with the data as is. We can store the data as rows and columns. We can store it as documents. We can store it as graph data and query it as such. And then, because we can store graphs and lists and so on, then we can create those ontologies on top, those taxonomies, and essentially create a knowledge model and a business glossary, along with the metadata. The metadata is, the active metadata is very important to allow us to work with, all those different types of records. And then, application layer, you need various APIs to allow you to access the data. Maybe it's ODBC, maybe it's via REST or something like that. Those we make available through the platform access layer.
Andy, you mentioned the semantic layer being a challenge in the sense that it needs to keep up to date with the business. I wanted to give you an opportunity to maybe ask questions about that, like a deeper question about how this can be handled.
Well, I mean, it depends on the particular technology in you're talking about, but in particular, I think ideally the semantic layer should have some sort of dynamic access to the database schemas, of the underlying systems, because you know, although people are not going to, you know, reorganize their product hierarchy every day, they may well reorganize it every few weeks or months. So it's something where the you know, the data catalog underneath this layer essentially needs to not just be something which is, you know, maintained entirely separately from the underlying database schemas of the operational systems. There needs to be some kind of trigger mechanism or you know, alert mechanism, or some sort of, you know, ideally some sort of API in a perfect world between the data catalog and the underlying database schemas, you know, to make sure that changes in hierarchies in particular, and that's the most obvious thing, are actually reflected. And indeed, additional sources may come in. There may be, you know, say something from an acquisition that you know, that has additional customer information, but about a new, you know, a new business segment or a new acquired company in a particular country. Somehow that's got to get reflected back into the data catalog, and from there into the semantic layer. So you just need to make sure that the processes are in place to that happens, and that, you know, may involve to a high degree sort of technology, but I mean, it will just depend on the particular databases and the particular capabilities of the catalog and semantic layer in question. But whatever the underlying mechanisms are, they need to kind of happen, because that's one of the things that I think made data warehouses sort of struggle a bit. You know, when I was much more sort of on, you know, doing this in you know, hands-on some years back. It was great to do the first iteration of the warehouse, and everyone was really happy for, you know, for a few weeks. But as soon as there was an acquisition, a reorganization, somebody changed the hierarchy somewhere and said, "Oh, hang on a sec, we will take us 6 weeks to reflect that change back in the, you know, in the schema structure." Well, you know, if you have enough changes, then after a while, it means that the in this case, data warehouse would get out of sync with the operational systems, you know, really quite rapidly, and it would decay in usefulness. And that kind of thing could, you know, happen in this structure too, if you are not able to tie the data catalog, you know, to the changes in the underlying source systems. And once, if you can make sure there's a curve, that's great, because then you will, you know, you'll be able to, you know, the semantic layer will then be driven from that catalog, and that will be up to date. But it won't happen by magic, is what I'm saying. It has to be, you know, someone has to put some processes in place to make sure it occurs.
Steve, do you relate to this dynamic synchronization magic?
Yeah, absolutely, yes. I mean, one of the things, so you can, if you think about the process, sorry, the systems that are extracting data from their you know, the original silos and getting it into so I guess the store that you're using to represent data that you can actually query, then it makes sense to make those systems, those programs, dynamic rather than hard coded. In other words, they consult the knowledge model, the business glossary, to work out, okay, so let's say to get the field names that they have to grab and pass up to the data layer, for example. And of course, so really what that then means is that you don't have to keep altering your code, the underlying code that gets the system, that gets the data in. You can just update your knowledge graph, your business glossary through a nice UI, and away you go, and you're sorted. Greatly cuts down on the amount of effort required to keep systems maintained.
Steve, could you speak a little more about the data catalog?
So these little screenshots here are views of Progress's Semaphore knowledge model management software. And you can see that if we start on the right-hand side, you can start off with a conceptual model. And that can then lead down into the more concretized logical model, which ultimately goes down to the data definition, the physical model of where that data is actually stored and the fields that you want to extract from those source systems. Now, all this is stored as a graph. It's stored as semantic triples. That can be stored in MarLogic, and it's something that you can query The other thing to note is that whenever you make changes to any the graphs at any level, that information is done through something called tasks. In other words, you create a task to change the model in some way, and then you can have people review that task or those changes such that you can be sure that the people who are reviewing that are experts, they know what they're talking about, and that changes aren't just made willy-nilly without some form of tracking. So I think that's very important to bear in mind, because clearly the only way you're going to be able to make a success of this is if it's well controlled in the changes that you make.
Steve, what would you say dictates the choice of data architecture then?
So I think whether you go with a data fabric, a data mesh, or stick with what you have would depend on the maturity of two main factors. So, for example, if you have good metadata maturity, that's really your knowledge graph, your data catalog, your business glossary, and other metadata surrounding that, and you have a good governance, not only at the organizational level, but at the line of business level, then you can probably proceed and go forward with a data fabric. And in fact, it's more important to have the metadata maturity than the total governance maturity. You can still go with the fabric. If you have good governance, but you don't really have the maturity in metadata, then really what you're doing is you're saying, okay, go with you're talking about line of businesses, go with a data mesh and work yourself up from there. And then if you get to the point where you have great metadata maturity, maybe migrate or upgrade to a fabric architecture. But then the good thing is, of course, is that you've got those mesh data products that you can then blend in. If you have neither, then really you've got to maintain your data lake or data warehouse and work on gaining maturity in metadata and governance before you can really start. Otherwise, you're just going to take a lot of detours and ultimately produce something that's going to fail.
Could we talk about some examples of successful data fabric deliveries from the field?
Sure. Okay. So Broadridge is a financial services outsourcer. And what they do, they've created a product, a post-trade processing product that they sell to financial services institutions. The idea is that the financial institution will give them their post-trade data for processing, and then they can start, querying it and working with it and get useful insights out of it. Now, the way that Broadridge has implemented this is that they'll integrate data from the various systems that have been imported from the client. But the key part here really is that they'll have they have an ontology for each client. That ontology describes the client's data. And so what will happen is it will translate that ontology into ways of describing the data such that they can query that information very easily without having to rewrite their queries for each client. So in other words, let's say one client might consider you might have F name to describe first name for one client in a table, first underscore name for another. So the ontology will take a note of that and then pass that down to the query layer so that that the queries are constructed on the fly, and you don't have to change you don't have to re-engineer your code for every client. And I think that's a key piece. That's a key part of the fabric. So you're using the metadata, the knowledge graph in order to be able to create that fabric. Let's go on to the next one. So this is a global food leader. One of the things that they were struggling with was trying to give useful, accurate, and timely insight to their business users. Now, these business users, they were getting access or trying to get access from multiple different systems. And it was very time consuming. They were having to do a lot of data integration themselves. They did create a lot of point-to-point integrations. The problem with that is that they ended up with like a bird's nest of interconnections, and it didn't really solve ultimately the business requirements. So because they've done this multiple times. They've tried various IT approaches, like I said, point-to-point integrations being one of them, and ultimately failed. And that's why they came to us. Next slide. So what we were able to do was integrate all that information, create a single source of truth that was really grounded in the data from those source systems. And we were able to make it available to the business users and any other downstream systems that required it. Now, I think one of the things that it's important to note with traditional approaches is that there tends to be a lot of ETL. With ETL, you invariably lose a lot of the lineage of where that data came from, the provenance, and therefore you lose, I guess, trust in that data. With MarkLogic, the way we work with, or the way we store records, we can very easily store that lineage, that provenance information within each record. And in fact, in that data, again, the way we work with the information is that or the way we store records, in some cases, eliminate very easily the ETL. So that it reduces the friction to get data into the platform, and ultimately increases the trust in that data. And then finally, of course, you've got the MarkLogic's ability to integrate with a whole host of systems, including the one that they were working with, Apache Pulsar, which is their messaging and streaming platform. So, very, very successful integration for a data fabric.
This has been a very insightful discussion. Thank you, Steve. Thank you, Andy. I see there are a couple of questions in the question panel. We can open up the conversations now. Gentlemen, yes, thank you. We can go off mute now. The first question I'd like to read out is, you talked about the problem of data contracts changing underneath the warehouse or semantic layer, which leads to costly rework. I missed how you addressed that issue. Could you clarify that?
Yeah, sure. So this comes back to the knowledge graph, really. If you've got your systems that you're using to push data to a central place, then yeah, it's important that they're created dynamically. You want to make sure that you're only updating these contracts in one place, and that storage for the contract would be that knowledge model, the metadata, the business glossary, the data catalog. You kind of rationalize it into a single place, so that you're not going to lose track of it, and it means that you can ultimately respond to business requirements that much quicker.
Thanks. Andy, did you want to add anything?
No, I mean, I think that covers it pretty well.
All right, the next question, let me scroll down, is what can you provide some guidance on how AI can be used within a data fabric to automate data integration, data quality, and governance?
That is an interesting one, because of course AI is the Gen AI is the new hot topic within the industry. So yes, I mean, you've got to be, it's a double-edged sword. You've got to be very careful, because you've probably heard of hallucinations, which is where Gen AI makes stuff up on the fly. So you've got to be very careful that that you train it well, and you're asking well-formed questions. What I would say is that you've got to make sure that whilst you can do a fair amount of automation with AI, I think you still got to have a human in the loop. You know, there are cases where organizations have had these AI run chatbots, and they've given incorrect information to a client. That client has then sued, and the organization says, oh, well, we're outsourcing our AI chatbot, you know, to another company. Well, you know, that company is fronting the other company's chatbots, and you know, it's no excuse. So I think there was all this fanfare about what AI can do, and I think now we're getting into the, you know, the place where the rubber hits the road, and we're realizing that these models are not perfect, and of course, you know, humans are not perfect either. So yes, you can proceed and you can use GenAI technology, and you know, we've got a great answer to, you know, how you can ask questions and get answers back. But yeah, you do need to have a lot of fair amount of checks and balances to make sure that you're not shooting yourself in the foot.
Yeah, I mean, just to add to that, perhaps, so I think you can rephrase the question as, you know, how do you use AI to, you know, sort of automate, you know, data governance and so on. I think it's a similar question to, you know, how do porcupines mate, which is carefully. And I think I mean, one thing is, I don't think everybody's aware necessarily of the degrees to which AI, generative AI, large language models can sort of misbehave. So somewhere around 25% of all generative AI queries result in hallucinations, and around 42% have some kind of error that's coming up. And some of them lead to all kinds of amusing things. You know, we're all seeing generated AI images with people with third or fourth leg and that kind of stuff, or extra fingers or whatever, and that's all kind of like mildly amusing, but less amusing if you're using AI to, you know, generate something like potential cases for credit card fraud, or, you know, trying to sort of scan a database for, you know, the airport for potential terrorists. Then the whole you know, hallucination stuff isn't quite so entertaining. In the case of SQL, which is obviously what we're talking about here, if we've got talking about structured data, you know, there are similar issues. You know, AI will hallucinate, you know, table names, column names, if, you know, and it will do so a lot if it's not familiar with the schema. So, you know, I was reading a study the other day, and I think the researchers tried to get a generative AI model to produce some SQL, and the raw sort of, you know, approach before they started to fiddle around with it was getting about a 3% accuracy response. And, you know, one of those issues was, how do you make it familiar with the schema? You know, so you can make it a lot better by feeding it the schema in a sort of giant prompt, you know, before you actually ask any questions. And you can make it better still if you give it example queries with results, the kind of things you're expecting. And then when it sees those things, the models get, you know, more, you know, get significantly better. So I think by the time they finished a whole part of sort of engineering, they got this sort of accuracy of these responses from about 3% up to a sort of 70 to 80%. So there's a lot that can be done to improve things. But as Steve said, you know, we're very much, you know, this is not a matter of you just give the AI, you know, free rein and have fun with it. You know, it's something where you are going to require a significant amount of monitoring, supervision, and you know, prompt engineering, you know, and having humans sort of in that loop, you know, reviewing things quite regularly. Because at the moment, and honestly, this isn't really likely to change very much either, you know, in the foreseeable future. You know, the current sort of, you know, technologies have, are potentially very interesting, but they do definitely have limitations and flaws.
That's an interesting discussion. We're going into the AI space. And then it's also an interesting follow-up question to the first question that I asked, actually from the same person. It reads, I think it's to you, Steve. I like your example of mapping f_name and name_first from lower systems to first name in the semantic layer. Does this mapping require manual intervention, or is it installed by AI?
So I think there's a couple of things here. One is, let's say that somebody in the source silo, maybe they make a change. Now you could argue that there's some AI technology that will go out there and say, oh, the last time I looked at this table, it was this column. Now it's this. It's kind of in the same column position, and there's a commonality of name and F in the column name. You could probably argue that, okay, it was reasonably safe to go back then and update the knowledge model with that information. But again, I would argue that you still need a human in the loop to validate that before you commit it to the knowledge model, the data catalog. Yeah, I think that's probably all I would say on that. There's, like as we were both saying, that there's only a certain amount of automation, because really what you've got to realize is that we think of AI as being kind of intelligent. I look at it as from the point of view that it's a child, really, and you've got to guide it on the way to making good decisions. And frankly, I don't really think we're there yet. The reasoning isn't fully there yet. Just the general intelligence, it's getting there, and I'm sure it will, but it's not there right now.
Yeah, I mean, the way to think about it, I mean, it's really just essentially, a generative AI or large language model. I mean, it's really just an autocomplete function on steroids. I mean, it's the sort of thing where you start your Google query and it puts the next few words in, and it's just that you can do this, but instead of a few words, you can produce paragraphs for a whole essay or a bunch of programming code or whatever. But I mean, that's essentially what it is, and I think it's important to understand that. I mean, as some AI researcher said the other day, because there are all these issues with hallucinations and errors, and often the AI model itself will correct itself if you say, oh, hang on, that doesn't sound right. Can you take me through the steps here, and then it'll produce a better answer. But as this researcher said, what was the last time your pocket calculator had to apologize to you for producing a wrong answer? And so, again, depending on the context, these things, it may not matter if you're asking the AI to give you a bunch of, suggested names for your new kitten, but if you're trying to get it to do something serious, like something operational stuff in a corporate environment, or in some, God forbid, some sort of medical environment, trying to sort of diagnose something, then you kind of really want it to be right most of the time, and and we're not there, I don't think, at this point. As Stephen says, I think at the moment there's still an awful lot of work required and an awful lot of human intervention. So there's a lot of things you can do, but you have to understand it's something that's going to help humans do things mostly, rather than replace humans doing things. Mostly. I mean, there may be some things it can just do, but in the majority of cases, think of it as a sort of, assistant or co-pilot or something that's going to help you, make slightly better decisions or save you some time, rather than something that's just going to come in and sweep away an entire job.
As a closing remark, Andy, I'd like to ask you, is the future of data AI, or are we going to probably see something more disrupting?
I mean, it's unclear. As I said, we talked a little bit about the current sort of iterations of AI at the moment. I mean, I'm not convinced that we're, from what I've seen so far anyway, that we're at a stage where AI is at the point of replacing DBAs or replacing programmers or replacing analysts. It's just there's too many issues. There's too much prompt engineering you have to do to even get it to come up with a reasonable answer. And so I think for sort of serious production implementations, I think you're still going to need human in the loop, at least for the foreseeable future. That's not to say there's not all kinds of useful things it can help you with. It can, but you do have to remember that it's a sort of emerging technology and it's imperfect, and people are still learning the limitations and issues of it.
Right. Well, we're at the top of our hour, and I'd like to thank you both for being such great hosts today. I'd like everyone for joining us today. I hope you join us next month as well. Little teaser, we're going to be talking about building search-driven applications, so hope to see you at the next one. Thank you.
Thank you very much.